Welcome back. How do we use worker threads? Let's put this shiny node feature to work. I've created a threads example folder, and I'm going to make a file that I'll call threads.js. To put our threads to use, we need to require the worker threads module. And I'll take a few different values from that module. The most important value will be this worker constructor that I'm going to destructure from the exports of our worker threads module. And similarly to what the cluster module allowed us to do, we can check if we're currently in the main thread or in a worker thread by using this isMainThread value that's also made available in our worker threads module. We can combine these two features to create new worker threads by calling new on our worker constructor. And the worker constructor takes a parameter, a string, that points to some file that contains JavaScript code to be executed in that worker. So what we can do is pass in the current file's path by using the __ file name value that's available in our node modules. So __ file name will point to threads.js. And as it stands, this code would create workers over and over until our machine can no longer create workers, right? Because we would run our program, it would create workers that run our program again, which just create more workers forever. So what we want to do is only create new workers if we're in the main thread, when we run threads.js for the first time. So we can check isMainThread and only then call new worker. Otherwise, what we'll do is we'll console.log that we're in a worker. To demonstrate how this might be used, let's create just two workers that both run the same code, the code in our current threads.js file. So if we run this, what do you expect to see? I can run node threads.js, and we have two worker threads that were executed, both with the ability to run our worker code in parallel. But let's demonstrate how worker threads are different from processes. Remember, worker threads are all part of the same process. Unlike clusters, we run node multiple times in one process. So if we console.log using our template string that the worker's process ID is equal to this built-in process.pid value, and we can do the same thing for our main thread, we'll console.log right here at the top that the main thread has this process ID. We should expect to see, unlike our cluster module, 3 identical process IDs. Let's see. I'll clear the terminal and run node threads. Check it out. Our main thread shares the process ID with both of the workers. All right, so this is all fine in theory. But right now, our worker thread isn't doing anything useful. Let's give it some actual work to do in parallel with the other worker thread. What work can we give it? Say we have an array of numbers, something like 7, 6, 2, and 3. Remember that our built-in JavaScript sort operation that we can call on any array was blocking. Say we wanted to sort a few different arrays on separate threads to take advantage of the multiple CPU processors on my machine. We can send work from our main thread to our worker threads by using this second parameter to our worker constructor, which accepts an object with a worker data property. We can pass in the array we want to sort in each worker as the value of this property. So say 7, 6, 2, and 3. And for the second worker, we can send a different set of data. So worker data could be 1, 3, 4, and 3. This data will now be available in the worker thread inside of this worker data value that's part of our worker threads module. So what I'll do is I'll move our imports all onto a separate line. And right below is main thread. If we import worker data, this value will now be set inside of each of our worker threads. Say we wanted to log it, we could do console.log and then say that the worker data, which is coming through our import here, is equal to that value. And we could then do the hard work of sorting that array and saying that this worker data sorted is equal to worker data.sort. Now, while this sort operation will block each thread, because I have multiple processors on my machine, the two different arrays that I pass in can be sorted in parallel, side by side. Let's see what happens if I run our program here. I'll clear the terminal and say node threads, and you can see what happened is the main thread started, and then each of our two worker threads started, both doing our sort operation more or less side by side. Sorting is a fairly expensive operation when it comes to how much of your CPU it uses. By using worker threads, we can multiply the effectiveness of our CPU by taking advantage of its multiple processors. Processors which can run each thread in parallel. And because we're using the worker threads module, all of this happens inside one process in the most efficient way possible. Good stuff. I'll see you in the next video.